All right, let's look at the discussion question number 9. So what I've given you is a vector field for a system of differential equations. So the thing we want to start with is from this vector field, estimating where the null lines are. So starting with x1. So essentially what we're going to do is estimate where dx1 dt is going to be equal to 0. So on a vector field, what is that going to look like? Well, x1 is being graphed on the horizontal axis. So if we have no change in the horizontal direction, then what these null lines are going to look like, these are going to be vertical slopes. So I'm going to be looking for where vertical slopes exist on the slope field. And it looks like right here I see a lot of vertical slopes along this horizontal line thereabout. And vertical slopes over here, which are oriented downward. And I'll go ahead and stop right there because it looks like as we get closer and closer to whatever this point is, I don't have any kind of behavior. I don't have any slope field there. So do I see any kind of other vertical slopes? If we look a little bit to the left of this white space right here, it looks like I mean, it's hard for me to say that this is a null line, this vertical space right here. But like I think as we approach this area, I have a lot of steep dy or dx dx2 dt slopes. But as far as my null line in that direction, I think that's the only one I see. So now let's look at a null line for x2. So x2 is the variable I'm graphing on my vertical axis. So what are those? What's it going to look like if dx2 dt is equal to 0? Those are going to be horizontal. So where do I see horizontal slopes? A lot of them right here. Also here. And I feel like I'm seeing some horizontal behavior in here too. So kind of just making an estimate where these are. I mean, no matter how densely you populate a slope field, you're not going to be able to see everything. But I think I have a null line there, and because of that, I think I'm going to estimate that I have a null line, over here as well. And this is a null line in the for dx1 dt. Okay, so I think I have my null lines. Estimate the locations of any equilibrium points. So where do we have equilibrium points? So we're going to have equilibrium points where anywhere where a x1 null line and an x2 null line cross. So let's do this. Now that we've done this, probably should have done this for parts 1 and 2. Let's label these lines that I drew with what kind of null lines they are. So there's an x1 null line. Here's an x1 null line because those are vertical. And then this is an x2 null line. And it's another x2 null line. So where are equilibria going to be? So let's just go. I mean, doesn't really matter what order we do this in, but let's be systematic about. Let's look at this furthest left x1 null line. Does this cross any x2 null lines? Well, if I follow it down, let's look at crosses this x2 null line. I mean, very near the origin. I will say 0.05, 0.05. Ooh, back up. 0.05, 0.05, I believe is an equilibrium point. What about my other x1 null cline? My other x1 null cline, so it crosses my other x1 null cline, but that's not equilibrium. That's just, for equilibrium, I need both of the differential equations to be equal to 0. So I think of like this, this white space here. I believe that's equilibrium. It looks like there's no behavior. There's no slope there. So what can I estimate about that point? It looks like it's 0.25, 0.5, something like that. 0.25, 0.5. All right, is there anything else? Does that x1 line cross any other? So that x1 null line is parallel to the other x2 null line. I believe that these are the only equilibrium points that I can find. All right. So now, can I talk about the stability at these points? So let's talk about 0.05, 0.05. It's hard to talk about the stability around that one because I don't have behavior, the only place that I see that deviates from this point is basically upward and to the right of it. I would like to see like more about the full surrounding area, but from what I can tell, it doesn't seem to be very stable. It doesn't seem like I have, my slopes are either, from above, my slopes are coming into this point, but they're not going to settle out there. They're always going to move to the right. And if they move far enough to the right, they're basically going to circle back around. So I would say this point is, unstable. And just kind of looking into the future here, in later sections, we'll be more specific about stability now that we're looking at two equations at once. But that looks to be unstable. What about this point, this 0.25, 0.5? This one I have a much better idea about. So I think if we pick a point like, let's just pick a point sort of nearby. If that's a point on a solution curve, what's that going to do? It's going to, it looks like it's going to just indefinitely circle around that point, never getting any closer or any further away. So maybe right now with the descriptors we have, it's hard to talk about the stability of that because we're not trending away from our equilibrium. We're not trending toward it. We're just trending around it. Basically, any solution curve around it is going to be, I don't know if it's going to be circular, but it looks like it's going to be a closed curve. It's just going to keep sort of circling around it. Maybe not in a circular path, but we're going to keep rotating around it. So for right now, I'll put closed loop. And with the promise that we'll give more specificity to what kind of equilibrium this is later. So that was 4. So for part 5, let's try to define the system. So how can we do that based on our null clines? So function f is the differential equation for x1. So what were the null clines I found for x1? Well, I think one of them I said was basically a vertical line and a horizontal line. So I think one of them, I'll say this. X1 minus 0.05. And why am I writing it this way? Because now that I know the null clines, basically I know some conditions under which each differential equation is equal to 0. Each individual equation is equal to 0. What was the other condition? Well, that's a horizontal line, so that'll be x2 is equal to 0.5. So x2 minus 0.5. One more thing I want to check here is that, do I have the right signs here? So, for example, let's say x1 is a little bit bigger than 0.05. Then what does that mean about dx1 dt? It looks like it's moving, it's slightly left. So that doesn't fit. So here's what I want to do. I want to change this 0.05 minus x1, because now this is going to have the behavior I want. If I'm a little bit left of this value, then I'll have I have slopes that are a little bit right. If I'm to the right of this point, or if I have x1 values that are greater than 0.05, like over here, for example, those slopes are a little bit left or negative. So I think this captures the behavior I want. Let's make sure of the same thing with x2. So 0.5, if I go above that, it looks like no matter what, actually that's not true. If I'm below this line, then are my slopes pointing right or left? They're pointing right. And if I'm above this line, the slopes are pointing left. So if x2 is, say, 1, then this term right here should be negative. So I think I have to make the same adjustment. 0.5 minus x2. So again, this is probably not exactly what the definition of the equation is, but based on the null clients, which is the best evidence I have, this is about as close as I can get. I mean, there is probably some constant here, because right now all I'm really going off of is the sign. So are my slopes positive, negative, or 0? And with that information, I think this is about the best I can hope for. Apparently I can't draw straight lines. There we go. All right. So what about g, the function that gives the differential equation for dx2 dt? So what are those null clients? One of them is a vertical line at 0.25. So before we write this down, let's see what happens on either side of that. So now we're looking at dx2 dt, which is essentially our vertical rate of change. So if we go to the right of that vertical line, we have upward movement. If we go to the left of that vertical line, we have downward movement. So I believe this is going to be correctly written as x 1 minus 0.25. Because if I say, let's say x1 is 1 out here somewhere, then what's the value of dx dt or dx2 dt? It's going to be positive because those slopes are upward. All right, what's my other null line for x2? It is a horizontal line, and we said it was at 0.05. So x2 minus 0.05. And do we agree with that sign? Easiest way to check is to pick a point above that horizontal line. So like 0.2. If I'm above that, I have upward movement. Because of that, I feel like this sign is okay. So let me call this constant K1. I'll call this constant K2. X minus 0.25, x1, times x2 minus 0.05. But yeah, that's one way to kind of go at trying to come up with an expression for those differential equations, but Yeah, so yours might be different, but they could be correct. I'll give you individual feedback on yours. That's all for this question.